Okay, welcome back, everyone. And welcome back to everyone on the live stream. We had a really interesting set of presentations in the morning where we had the Progress Prize winners. Now we're going to tell you about a different kind of prize winner. So one of the things that we wanted to do in setting up the challenge is not just encourage people to focus on predictive performance, but to encourage them to focus on other things as well. And so we established a prize for the person who most helped other people during the challenge. So the idea is, if this is going to be a mass collaboration, we should recognize it when people do things that help others. And so throughout the challenge, it was incredibly heartwarming to see how many people shared their expertise. Many participants open sourced their code while the challenge was going on. So that was wonderful. And we're going to hear now from Greg Gundersen, who's a PhD student in computer science at Princeton. He first encountered the challenge in the undergraduate machine learning class that Julia was in as well. And he's continued his research with machine learning, and his main area of research now is in statistical and machine learning methods for genomics data. And while he was working on the challenge, he built this amazing thing that turned out to be really helpful for many other participants, which we heard from them about, and also turned out to be really inspirational to us, the challenge team. So let's hear from Greg, and then we'll tell you a little bit about what we've done subsequently.
Thank you. As Matt just said, my name is Gregory Gundersen, and I am a PhD student in computer science here at Princeton. And while my area is machine learning and I work with Barbara Engelhardt, today I'm going to present a tool that's really just a tool that hopefully makes accessing the metadata about the Fragile Families data easier, and the process of sort of onboarding people onto future challenges or getting started with the data simpler. So the takeaway I hope for you is that you think it's useful and ideally want to sort of have ideas for continuing to develop it. For what it's worth, it's like maybe 200 lines of Python, so I'm very happy to continue maintaining it and like integrating new features if people have ideas. So you've already seen this a number of times, and maybe this type of view of the data says something about me. But the Fragile Families data, if you were to download it, if you're like me and you're maybe not an expert in the actual data and how it was collected, and you're just sort of looking at it for the first time, it's a bit overwhelming, right? There's a ton. There's 4,200 families and roughly 13,000 features or variables. And one of the things that sort of confused me when I first started looking at it was simply, what is this label? So for example, all the columns have these different labels, and here we have M4A3, right? And if you know the Fragile Families data, you might know that M stands for the mother or something like this. But for someone like me, even if I wanted to do feature selection with eviction, which is what I was predicting, and I'm not an expert in eviction, but even if I wanted to do that, I couldn't even find which features related to eviction. So this is a problem that I sort of wanted to solve. Now, there is an answer to this question, and it's here. So on the Fragile Families website, there are these TXT files and PDFs. Here's one of them, and this one contains the answer to what is M4A3. So it's how many months ago did he/she stop living with you? As a sort of a side note, I did some methods that encourage sparsity to see if I could find which features are most predictive, and this was what was most predictive for eviction for me. So I wanted to know what it was, and here is the text file that it would be in. You may ask sort of what's wrong with this data format, from my perspective, like how to improve it. I think the first thing is that it's just hard to find, again, if you're new. So I think Matt and Ian can attest that throughout the challenge, I would email them and say, like, I'm interested in this thing. Where do I actually find it, right? So there's a lot of different surveys over time. They're in different formats. And so it's kind of hard to find if you don't know where to go. It's also hard to access. And by access, I mean programmatically access. I think a lot of people want to be able to, say, use the data directly in, say, R or Python or some sort of programming language. And because the data is sort of loosely structured in this text file, you have to write some sort of custom script to sort of automatically find, like, when you see a bunch of hyphens in a row, that's the start of a new question and things like this. It's not structured in the way that you might expect, let's say, a web API or something, which is ultimately my solution. And then finally, it's also hard to search. So if you wanted to just look for keywords like evict, rent, money, abuse, if you want to search for things that you think might be relevant to what you're interested in, it's sort of hard to do in this format, once again, because it's sort of loosely structured and scattered in a couple different formats. So my solution was to build a web-based metadata API. And so if you've never interacted much with an API, I'll just sort of explain it at a high level. APIs map, or web APIs map URLs to data and operations on data. And these are really common in the web development community. The most, maybe a good example is like Twitter, right? So you have tweets, and you can go to twitter.com. But if you want to, say, get those tweets programmatically for a specific user, let's say you want to download all the tweets from a particular user or a class of user, you can use Twitter's API. And so you have to go through some onboarding process with Twitter, you do some authentication, and then they actually give you access to the data programmatically. And the way you would do that is you would actually make these requests to URLs. And we'll sort of talk about this a little bit in more detail in a second. Or rather, I'll demo it. I guess I won't go into more detail, but we'll demo it so you have some intuition. And then the other big thing that it does is it returns it in some sort of structured format, so usually JSON or XML or something. So why do I think this is kind of a good solution? One is that it's a sort of a global communal entry point for the metadata, right? So you don't have to download any extra software. We can make updates to the software behind the scenes, and you don't even know that the software is being updated. You just go there and you hit the URL endpoint again, and suddenly there's more data. And then finally, you can access it programmatically through a variety of formats. So you can go in your web browser and just look at the data. You could also use R or Python or your favorite language to actually just make the URL request and get the data this way. And just to be kind of clear, because the Fragile Families data is sensitive information, this is only the metadata, right? So you can also sort of control what people access through these kinds of things. So with Twitter, right, like if you were to go use Twitter's API, they'll actually control what metadata you can see, and if you pay them money, I'm sure they give you more data, right? So we're not exposing any of the original data, no statistics. It's just the metadata that's in the surveys and things like that. Okay, so without further ado, here's just a simple demo. So here's 3 URLs, and each URL returns a different sort of subset of data and a different operation on the data. So I'm just going to actually click on these and open up my browser. So here you go to CodaLab, fragilefamilieschallenge.org, and then at the very end, the only important thing is that M4A3, and that just tells you, give me the metadata for this. And it's opened up in a different screen. Let me just drag it over. So here is, and Firefox is rendering the JSON prettily for you, so it's like blue labels and purple values. And this is the metadata that this API serves. So for example, it tells you the code, the description, label. It even tells you the source file of where to find the original data. Let's see if I can switch back. I don't know where my presentation went. Where's my presentation? Yeah, I can just drag this over, I guess. Sorry, I'm just going to pull up. So the other feature that I wanted to build in is search. So here is sort of the Google standard. If you just do Q and then a search word term, Google will tell you everything from the query. Here, if you actually click this and open it up in your browser, it tells you all the terms for eviction. Sorry, or rather, all the descriptions that contain the word evict. Sorry, I'm having trouble with the actually sizing of the windows. Let's see if I can actually drag it all the way across without it collapsing on me. OK, so here are all the metadata items that contain the word evict in the description. And this is nice because obviously I can come here and I can just change this to equals rent, and it'll just do the same thing. You can see it actually returns more data, and then I can go in and look at, actually I think this is actually returning something with the word parent. So this allows you to sort of quickly parse through the data and just sort of see what is available. And then you can actually download all the data. If you hit the final endpoint, it'll actually just return all the data. And this is nice if you just want to download it using a scripting language. So again, this will tell you very quickly like what data is available. OK. Let me see if I can get back into presenter mode painlessly. OK, and so the other thing I just want to show is just some Python code just to demonstrate that it's not a browser-based solution. It is anything that can make a URL request. So here's some Python 2 code that actually makes a GET request, right, and like downloads the data, and then you can actually say filter the data however you want. So I think this is why I like web-based solutions, is because you can use a variety of different techniques to access the data. OK, so then future directions. One thing I did, so this was, I was taking Professor Engelhardt's course, and I just wanted a rough cut of feature selections. If a problem was hard, I avoided it, right? So I didn't actually handle PDFs at all. So not all the data is included. I don't think it's actually that big of a problem from a technical standpoint. You probably just need some software that converts a PDF to text and then parse that. But I think just including this would be useful. Standardization, which I think we're probably going to talk a little bit about in a few minutes, so I won't go there. Documentation is important. I think there's a blog post on this, but often it's useful to have like a single page that just says, here's the exact URL you would use. Here's the exact Python code that would work for these examples. So you notice when I typed rent, it gave me parent. A regular expression search is basically just more expressiveness in what you're searching for. So you could restrict, say, like, I only want rent, but nothing in front of the word rent, right? So parent would be excluded. So I think a finer grained search, again, probably not that hard to do, but just something that I haven't had time to do. And then also I think filtering by label. The metadata already has labels. I think that would be kind of a nice thing to do. Also by wave, maybe the number of responses. It'd be really cool if you could just say, like, give me all the metadata that there are 0 responses for. And so that very quickly would tell you something about the data. And this may be getting too fancy, but if anybody wanted, like, again, because it's an API, you could build a web interface on top of it, right? So you would just type in the word evict in some like, key bar, and then it would like render it nicely for you. So something like that is pretty doable. Anyway, so it's open source. It's just on my GitHub account. You can download it and run it locally pretty fast, I think. And feel free to email me if you have any questions. So that's all I have.
So in addition to helping many of the participants, this idea of creating a metadata API was very inspirational to us. And pretty much as soon as the challenge started, we started receiving questions like the questions that Greg asked about people wanting to access the data. So when the data, as you heard, this is an ongoing study that's gone on for many, many years. It's had many, many modules that were organized by different groups. And the way that people in the challenge wanted to use the data was different than the way that I think the data was ever intended to be used. So normally, the way social scientists analyze the data would be to pick, let's say, a dozen variables and carefully clean and prepare them, and then run a regression on them. And many of the people in the challenge wanted to run a regression with all 12,000. And so if you think about the amount of time that goes into cleaning 12 variables, that is a pain for a social scientist, but it's a pain that we live with. But then if you want to scale that up by a factor of 100, it becomes a barrier. It becomes an insurmountable barrier. And so what we wanted to do is make it much easier for people who wanted to use all 12,000 variables at the same time. And in that process, we were going to make it much easier for people to use who just wanted to use 12. So we saw that there were lots of opportunities for ways to make the data easier. And the challenge was wonderful for discovering those, because everyone told us about their problems. So this is a great way to find out what are the problems with your data, is open it up and have lots of people tell you about their problems. And also tell you about their solutions. So for example, Greg told us about how he did what he did. Many other people shared their code. And so what we saw is questions that came up a lot or solutions that people built a lot. We decided to bring those in-house and try to improve them and do them even better. And so what we're going to show you now is what we've done since the challenge. This is our version of the web API. A lot of this work was done by Maya Phillips, who's an undergraduate. This is part of her independent work project. So we've put in a lot of time in actually building better and richer metadata. We've rebuilt the interface between that and the world. And then we've also built this front-end website. And so Alex is going to demo the website now and talk a little bit about how it works. And then we'll have a panel discussion about data availability, metadata, and so on. So Alex?
So I'm going to run through just a couple of quick features that we've built. Oh, uh-oh. Cool. So I'm just going to run through a couple, quickly run through a couple of the features that we built. As you sort of saw with the API demo, there are really like two things that we want to do with the metadata. We want to be able to search, and we want to be able to get metadata on a specific variable. So we'll start by searching. This is an interesting format. So the first thing that we can do is we can search for, say, health. We can go ahead and search for that. And then we see that we can get all the variables that include health in the description. The cool thing about this is we can also filter by these different metadata fields that we've added as a result of sort of interest in more structured metadata. So we can say, I want of all the health variables, but I only want the ones in the year 3 survey. So we can go ahead and filter by that. And then we see that these in fact are the variables that we filter to. We can also click into just looking at a specific variable. So we can look at this variable about how is the child's health in general. Then we see the parameters on this variable. So we see the description. We see it was in year 3. The respondent was the father. So this is the father describing the child's health. And then we have information about the type of the variable. We get the response code to the range of possible values, and more parameters on things like the where in the survey it was, maybe what the category or sort of the more general area that the variable belongs to. This one hasn't been categorized yet, and then a set of related variables that describe a similar thing. So we can see that these are all descriptions of the child's health from different respondents. Yeah. And then tags also, the conceptual tags? You mean? Okay. I think we already covered that. Yeah. Okay. So behind the scenes, we're still sort of working on the tagging to get the most sort of like rich set of tags possible for describing the metadata. So this is very much a work in progress.
Yeah, so in addition to being able to search through the actual question texts, sometimes a question about, let's say, gaining or losing weight is actually a question about mental health because it's part of a mental health scale. And so a simple question text search is going to miss some of the ways that these questions are intended to be able to link to social science constructs. And so a number of people on the Fragile Families team have been going through and tagging all of these with the appropriate, creating an ontology and then tagging them with the appropriate social science constructs that were intended to be captured with this question. And so when people asked about, for example, I would like to see all the questions related to schooling, those will not just be the ones that include the word school, but they can include lots of other things. And so those will all be tagged, so you'll be able to pull those out, and you'll be able to pull them out in combination with other things. So I would like all the schooling questions that were asked to the mother in wave 3, or any combination of things. And all of this, in addition to being accessible through the website, will also be accessible through, as Greg pointed out, Python, and we also have a student now who's interested in building an R package to make it easy for people to access this in whatever their development environment is. So if they prefer the web, great. If they prefer doing it through R or Python, that's great too. So now we'll have a panel discussion, because I know that many of you all had experiences with this during the challenge. So are there any questions about the metadata yet?
Question for Alex. With the tagging, maybe you mentioned it yesterday and missed it, but are you considering like a collaborative tagging approach where anybody that uses your site can create a set of tags that then appear for everyone else to see, or is it user based in any way?
I have two answers. So one thing is that yesterday during the first part of the workshop we had a sort of like collaborative sort of like we have a tagging procedure, and then we had a bunch of people sort of test it out. So that's one way in which we've tried to sort of build in collaboration. I think that in the future it would be really cool if we could sort of like accept user modifications or like sort of like user contributed metadata. So people have talked a lot about things like if somebody like develops a scale that incorporates several variables, then they would like to be able to sort of add that to the database and make that publicly available to people in a centralized place. And I think that this is another sort of great example of like ways in which we could sort of get the user community to sort of help contribute to the metadata. Yeah, so that's based on so it's a mix of like an algorithmic approach and a manual approach. So the first thing that we do is I guess I don't have it up anymore. So the first thing that we do is we compute the edit distance between the variable labels. So like the way that it works is, so if you have two variables and they say like, one of them says, in general, how is your child's health? And then the other one also says, in general, how is your child's health? Then we know that those are probably pretty closely related. So we sort of manually group them algorithmically in that sort of way. And then we sort of set like a conservative threshold on like how close the labels have to be in order for them to match. And then we've sort of manually gone through and sort of ensured that there aren't any sort of like false groupings or false positives in the data.
I have a question about, I guess, novelty. Are you seeing other departments doing the same thing with their code books, or are you all kind of, this is the first time this is being done, and will you be sharing your techniques with other departments, sociology departments?
So yes and no. So or on the question of novelty. So I think that a lot of sort of comparable surveys are moving in this direction. So they're wanting to make their data more sort of like programmatically available. I do think that this is sort of like relatively cutting edge. So I think we would really like to see more people move in this direction and make things like Python packages and R packages for their metadata available. We were kind of inspired by, so the census has an API for the census data. And so that's a sort of example of something that we found really cool and wanted to sort of bring out here too.
Also, in terms of sharing the lessons, we have a paper that's going to be part of the special issue of Socius about making the analysis of complex survey data more reliable, enjoyable, and fast, and less error prone, I would add also. And so through that, we'll talk about some of the experiences that we had during the challenge, and then some of the principles that we tried to follow in terms of making the data easier to use. I think the number one principle is to think of this metadata as data. And so that means like we would not release data in PDF format, we would release data in CSV format. And so if you think there's so much actual data in those PDF files about how the data was created, how it's stored and analyzed. And so the main principle is to sort of get that into a format that's easier for computers to access. And then also, I would say a second principle is to build more expert knowledge in a way that's easier to access. So the tagging, for example, that requires a lot of expert knowledge about the concepts that were being considered when the questions were being created. And right now, that expert knowledge is available to students here at Princeton who can talk to the people that made the questions. And and it's not accessible through an API though. And so we think that getting that expertise in a format that's more accessible to everyone will be really helpful. Okay, so let's have lunch, and we'll come back for more talks at 1 o'clock from other prize winners. So thank you, everyone.
I have one question.
Oh.
So I've noticed people are slowly plugging their laptops into these plugs here, and I just want you to know that these plugs only work if the cord under the table is plugged into an outlet underneath. So if you have any trouble with that, come find me.
Okay, see everyone at 1 o'clock. Enjoy lunch.